Hi everyone. In today's lesson, we're going to talk more about probability. Now we're going to talk about how to calculate it. So the probability of an event occurring is calculated by dividing the total number of outcomes by the total number of possible outcomes. Probability can be expressed as a decimal or a percent, where all probabilities must be between 0 and 1 or 0% and 100%. So let's see how that makes sense through a couple of examples. What is the probability that a person rolls a die and lands on a number greater than 6? Well, you should know on a six-sided die, the numbers go 1 through 6. So this is not possible. So the probability that this happens is a 0% chance. So this is never going to happen. So this is a 0 probability. Now, what if I did the reverse? What if I said, what is the probability that a person rolls a die and lands on a number less than or equal to 6? Well, all numbers on a die are less than or equal to 6. So the chances that somebody does this is 100%. This is certain probability. And this really just shows you the range of probabilities. It's either between 0 or 100. It could be 100%. It could be as a decimal, 0 or 1. All right, let's keep going. So there's something called theoretical probability, and this is probably something that you're very used to. Theoretical probability is probability based on what should happen. So let's just say Jack rolls a six-sided die, and I want to know what is the exact probability that he lands on an even number. And by saying an even number, I just mean what are the numbers that are even. So on the die, we have 1, 2, 3, 4, 5, and 6. So my even numbers here are 2, 4, and 6. So the probability that he lands on an even number theoretically should be 3, because there's 3 even numbers out of the six sides that there are. And if I reduce that, that's the same thing as saying 1/2. Theoretically, that's what should happen, but that might not always be the case. Example number 4, Sarah flips a coin. What is the exact probability that she lands on heads? Well, there's one head out of 2 possibilities. So her answer here should be 1 out of 2. The probability that she lands on a head should be 1 out of the 2 possible options, 1/2 as well. That's what should happen. And that leads me to empirical probability. So with empirical probability, it's probability based on what actually happens. So this is Jack. He rolls the six-sided die, but this time he rolls it 14 times and he records his results below. The question that I'm asking you now is what is the exact probability that he lands on a 6? Theoretically, if he was going to land on a 6, 1, 2, 3, 4, 5, 6, there's only one 6 out of six options. So theoretically, the probability that he lands on a 6 is only 1 out of 6. So this is theoretically. So let's see what happens empirically, or if he actually does it. So these are his rolls. They add up to 14, right? That's 7, 8, 9, 10, and then 4, 14. So based off of this, what's the probability that his next land will be a 6? Well, he got, which it looks like, he got rolled a 6 4 times. So 4 out of his grand total of 14 would be his probability. Now, if we simplify this a little bit by dividing top and bottom by 2, we would get 2 over 7. Now, is 2 over 7 exactly the same thing as 1/6? No. This is what should happen, and this is what did happen. So based off of what happened these 14 times, his probability is 2/7, where theoretically it should be 1/6. All right, let's move on to the next example. So now we're back to Sarah. Sarah flips her coin, and we want to find the exact probability that she will get tails on her next toss. Well, we know the theoretical probability of her landing on tails is 1 out of 2. So let's see if that happened to her. She flipped the coin 10 times and got tails 4. So the chances that she gets tails again would be 4 out of the 10. which reduces, if you divide top and bottom by 2, 2 out of 5. So this is what happened, 2/5. This is what should have happened, 1/2. It did not, and that's okay. That's just the difference between theoretical and empirical probabilities. Okay, next I'd like to discuss the probability of multiple events. So let's just talk about example 7. A bag of marbles contains 5 red, 6 green, and 4 blue. What is the exact probability that a person selects a red and then a green marble? So honestly, all you have to do with these problems is just multiply. So we're doing this more than once, so we have to multiply the different possibilities. So if I want the probability that a person gets a red and then a green, so the probability of red, this is the notation that I'm going to use for the probability of red, and this is probability of green. And we want to multiply them together, and that will give us the probability of getting a red and then a green. So probability of red and then a green. Okay, so we're going to multiply them together. So the probability that I get red, well, the bag contains 5 red marbles. Well, what's the total? I think all we have to do is just add up these options, right? 5 and 6 is 11, 11 and 4 is 15. So there are 15 total marbles, 5 of them are red. So the chances of picking out a red is 5 out of 15. So then my next draw, I want it to be green. Well, if I've already taken out a red, shouldn't I only have 14 marbles left for my total? And then how many greens do I have? I have 6 green marbles, so the probability of getting green will be 6. And then all you have to do is multiply these two together. So remember, when we multiply fractions, we do tops times tops. So 6 times 5 is 30. And then bottoms times bottoms. I'll help you out. It should be 210. And then all we're going to do is reduce that fraction, and we can use our calculators to do so, and you should get 1/7. So that is the probability that a person would get a red and then a green. Okay, let's look at the last example. A bag of marbles contains 5 red, 6 green, and 4 blue. And I want to know what is the exact probability that a person selects 3 green marbles in a row. So 3 green. So same example as before. So in order to get this, we need the probability of green the first time times the probability of green the second time times the probability of green the third time. Well, we know this is the same example as before, so there are 15 marbles total, and there are 6 marbles to choose from, so 6. Now, the second and third are based off of this first one. So if I've already selected a green marble, then I have to decrease the number of green marbles available. So I should have 5 available, and that decreases the total number to 14. And then if I have 2 marbles taken, that reduces it to 4 marbles, and then 13 as my total. So you always have to reduce if you're assuming that if I am assuming that this one's been taken out, assuming that this one's been taken out. So go ahead and calculate this and hit resume when you're ready for the answer. All right, so when you multiply the tops, you should be getting 120. And when you multiply the bottoms, you get 2,730. And if you reduce the fraction, you'll get 4/91. So that would be the probability of selecting 3 green marbles in a row. All right, if you have any questions, please make sure you ask us in class tomorrow, and that's it. Have a great night.